Baruch, we're grateful to have you here.
Yep, thank you very much for having me. I am ready and all set. So let's dig into it. It's starting to be evening. So here we go. I hope you can see my slides. I think you can.
Yep.
And let's get into it. So this is what you need to know about this talk, that it goes into a lot of pretty like beginner and basic concepts about Docker that might be very well familiar for the Kubernetes meetup attendees. So if you want kind of to dig into something deeper and make a more advanced discussion, feel free to stop me at any time, and we will just get into the glory details whenever you want. Without further ado, let's talk about best practices in implementing container image promotion pipelines. It's a mouthful, but it's actually very basic concept, as I mentioned. Now, I have to admit that every time I mention containers, I still refer to Docker, and that's just because yes, there are other implementations, but I guess we will all agree that Docker still has the absolute majority of the market, and the percentage of the other implementations is just too small to talk about them just yet. And when we talk about Docker, it's a little bit like that. Well, this is true for every software that I know, at least. The more I learn about software, the more I dislike it. And if you wish, that's like the visit to the sausage factory. And that's true about Docker as well. And the problem with Docker that we see a lot is that this feeling of, am I 100% sure that what I'm deploying to production is what I intended to deploy? So today we're going to talk about why it happens and what we can do to prevent it. My name is Baruch Sadogursky. I'm the Chief Sticker Officer of JFrog. That's my real business card, and that's like a sticker, appealable part of it. I would be happy to give you some stickers, and I will next time. We will do it in real life and offline. But for now, head of DevOps Advocacy with JFrog, at JBaruch on Twitter. That's what you take from this slide. This is my California disclaimer, as we are both, me and Deep, are in our Sunnyvale office. You can see here a chart from an amazing book called The Culture Map by Irene Meyer. I highly recommend everybody who work in a multicultural environment, which means everybody, to read it. As you can see here, the most emotionally expensive and confrontational people in the world are from Israel and Russia. I happen to be from both. So if I don't offend you today, that's my fault. Always feel free to connect on Twitter to get offended. Yes, that's me. The most important slide of today is this. If you go to jeffrog.com/show notes, you will see a page dedicated to this meetup. On this page, you will find the slides already there. The video, it has been recorded, so once it's I will get it, I will share it with you on the page as well. All the links, including the culture map that I mentioned, but everything that's coming as well, the place to comment, to rate, and as both Ari and Deep already mentioned, a raffle that you can participate, win a Nintendo Switch, and get a t-shirt just by participating in it. The link for this page is also on the bottom of every slide. So whenever you want to go there and check out the links, it's all here. So let's talk about promotion pipelines. When we look to implement a certain methodology, we usually look at an existing pattern and see if we can adapt it. And promotion pipelines are definitely a pattern that exists, and it exists for 20 years, since Agile, since 2000, actually 20 years. And this is something that we know how to do. That's a representation of promotion pipelines as a promotion pyramid. You have a lot of builds in the beginning of your pipeline. A lot of them fail. Some of them survive. They get to the next stage when the where the tests are longer, but you have less builds all the way to production. Or if you want to look at it this way, this is a promotion pipeline. So you see here how sources are built. And once you have your binaries built, you start the promotion pipeline. And then you have those quality gates that you promote the artifacts through the quality gates between different environments. So you have a space, a repository, if you wish, that you have your artifact in. And then from this space, you deploy it to corresponding cluster, and this is where you run your tests. And if the tests are satisfactory, then you promote your artifacts to the next space. And here again, you deploy to the corresponding cluster, run the tests, etc., all the way when you get to production, or you don't get to production, which is fine as well. Now, surprisingly, this concept that is not new, and I bet familiar for everyone here, if you maybe not doing that or not doing it that way, at least you know that that's the way it should happen. With Docker, a lot of companies, a lot of organizations, a lot of people don't do it this way. And the reason why not doing it this way comes from two opposite directions. From one direction, implementing promotion of Docker artifacts is much harder than it should be. And that's because of different reasons that we will get in a second. The other reason is that promotion of building Docker from sources is very, very easy. And what I'm talking about is you can just run Docker build. And Docker build works. Docker build works fast. And basically what you want to do now is Docker build all the things. So instead of building this one artifact and then promote it through quality gates, instead, what a lot of people trend to do is promote the source file, promote the Docker file. And by promoting the Docker file, what I mean is just tagging it with different information about the environment. And then when it gets to this environment, build a new image every time and deploy it to a corresponding environment. It's very tempting because promoting if one source file is just retagging it, and promoting a Docker image is actually dragging a relatively big artifact. Docker images might not be small, through different registries and environments and what's not. Sounds like a good idea? Not necessarily a good idea. Fast and cheap builds are not always the way to go. And they are not always the way to go because when you rebuild the same image over and over again, chances are you will actually end up with different images. And this is because Docker image is a pretty unstable thing to build. Docker file is pretty unstable dependency management declaration to rely on. And if you think that this is a bad Docker file that I probably invented to show you the horrors of an unstable Docker file, it is not. You can go to jfrog.com show notes and see in the links a reference to this very file on GitHub, open for everybody. Tons of people use it. This is how you run microservices with Python and Node. But this is actually really bad. And it's bad because this is the latest version. Every time you rebuild, you might get a different version of Ubuntu. This is the latest version. Same with Node, same with Python, and even dependency on your application is of the latest version. Your application might change as well, and you might end up with different with different image. So if you're going to rebuild this image for each and every environment, you might very well end up with a different image in production than the one that you actually wrote and tested. Well, this is where you, experienced people with Docker and Kubernetes, tell me, well, don't do that, right? Don't use latest. Let's nail it. Let's use 1904. Is it better? Well, to some extent. And it's better to some extent because obviously now we won't get 2004 on 1909, but still, Docker images, Docker tags are not immutable. It means that Canonical, the maintainer of Ubuntu, might decide to push another version of an image to Docker Hub and still tag it 1904. They have good reasons to do it, security vulnerabilities, whatever, but still it doesn't change the fact that it might change whenever Canonical decide it might change. We can still nail it further by using checksum. This is nice. Checksum actually always correlates to an immutable array of bytes, to the same array of bytes. So this is immutable. The problem is it's not very user-friendly. Do you know which version of Ubuntu I'm relying on now? Do you know if it's even a valid checksum, or my cat just went through the keyboard and this is what it typed? We have no idea. And you know what? Let's say since we are in a Kubernetes meetup and we all know Docker, we know that using checksum here provide us with immutable base image. What about the rest? Do we know how to nail those versions down? Do we know what happens with transitive dependencies if we nail those versions down? We might know apt-get, and we might know that it's possible, but what about Maven, for example? This is a Java build that uses Maven as a build tool. A person who doesn't know Maven might say, well, I don't know how to nail all the versions. A person that knows Maven might say, well, I know how to nail all the versions. Person that knows Maven very good will say, well, I don't know how to nail all the versions. In any way, it can be anything. It can be just your script downloading a bunch of random shit from the internet. Docker file is extremely non-deterministic tool to run your builds. And I will make even broader statement. In today's complexity of the modern software, almost all the builds are not reproducible. They might be reproducible to some extent. We might have some way of some degree of confidence about them, but in the end of the day, everything more complicated than a hello world is probably not reproducible. And if we use non-reproducible builds in our environment, when we actually rebuild in each and every environment, this is how we end up with different versions than in production than we built or we tested. So in the end of the day, this is my point. This is why you have this eerie feeling of, well, does it really run what I wanted it to run? And this is the problem. So let's solve it. Let's build a promotion pipeline that promotes immutable and stable binaries instead of rebuilding every time. How do we do that? We build once, and then we promote the same image through those quality gates that are here, promote, 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 all the way to production. And I'm keep talking about those gates. What's my obsession with gates? Well, gates are extremely important because this is what guarantees that the QA shouldn't test, that won't test dev environment, that non-stages images won't get to staging, and obviously the non-tested or development images won't end up in production. So let's see how we can build this pipeline with immutable binaries in Docker. And I already kind of alluded that it won't be easy. Let's see what actually is going on. Let's build a rock solid pipeline, and let's answer the question, how do I separate development from production? So you have number of options. you have labels, Docker labels. Docker labels are tags, key value tags that you can tag your images and say key maturity and then value dev or staging or prod, which is nice, but then you need to build an entire infrastructure that makes sure that you annotate your containers with the right labels, and then you know how to admit only the containers with the right labels into your environments. And all that is string based. One typo here or there, and all your verification worth nothing. So this is nice, but we can do better. The other option is using Docker repositories. Docker repositories are isolated spaces inside your Docker registry that you can apply role-based authentication permissions. And this looks like a good solution, but you need to remember what is the goal of the repositories. The repositories in Docker registry are a concept that is borrowed from the source control, from GitHub. And the repositories on GitHub don't have this separation of maturity because sources are sources. They are a maturity level by itself. This is like a very first step before any tests are run. Those are just sources. So they don't have sources on different levels of maturity, and repositories are there to separate your Docker images based on projects. This is how the repositories in source level world, and this is what they took over. So we can abuse them, not very intuitive, and definitely not what it's designed for. What we really want is having separate registries per environment. We want a registry for integration, we want a registry for system testing, registry for staging, and the registry for production. And this is great because this is how you can guarantee that then your production Kubernetes cluster will only communicate with the production registry. It won't even know about anything else because it doesn't have access, it doesn't know about it, and it doesn't have the right credentials. So isolating the environment per registry is very, very easy and very reliable. But with Docker, it's not so easy. Why it's not so easy? Well, that's kind of a limitation that it's really trumped up, but it's stuck with us now with Docker all the way. And this is how Docker tag is built. So Docker tag reuses some notions of a URL to provide its coordinates. So when we do Docker tag, we provide the host, we provide the port, and then we provide the username, and we provide the tag, the label and the tag. Sorry, the image name and the tag. So we don't really have any token to express which registry in our host this image should be tagged into. So there is no easy way to have more than one registry per host. This is, for example, a typical scenario on how we build repositories in our Java, .NET, JavaScript, Python, or any other dependency management. We have spaces separated by quality: dev, QA, staging, prod. With Docker, there is no way to express it because on one host and port, there can be only one registry. So what do we do? Except of panicking, we can do some neat tricks. The first one is URL rewriting using virtual hosts and virtual ports. How do we do that? How do we translate this into this? Well, we have something that we rewrite our requests. And here's an example from Nginx. We have a virtual port 5001, and every time we have a request for an image on port 5001, we actually know that this request should be forwarded to Docker dev. If we have 5002, it can go to Docker staging, etc., etc. Now, this actually works. This is one of the ways you implement multiple Docker registries in JFrog Container Registry or Artifactory. But we can actually go better. We can eliminate the dependency on this rewriting man in the middle, being it Nginx or being it Apache HTTPD or HE proxy, eliminating it by abusing something that we never use. So this username token, we don't use it anyway because it is intended for publicly sharing images. This is a concept that Docker needed for Docker Hub. But we are not in the Docker Hub. We are implementing our own registry. So instead of using a username here, we can easily use this for specifying which registry exactly are we going to use inside my registry host. So this is fine. Now we have multiple registries in a single host. The next question is, how do we promote? Because usually moving images from registry to registry requires a very intuitive process of pulling, retagging, and pushing back. And it actually makes sense if the registries are in different hosts. You need to somehow move from one to another. There is a network involved. That's fine. But this is not our case because we just put all the registries in the same host. We definitely shouldn't now download, retag, and upload back. So what we can use is a tool that knows how to do this promotion inside a single host, inside a single tool, without any network costs or even any disk costs at all. So let me show you. This is how JFrog Container Registry, JFrog Artifactory, JFrog Platform works, and there are probably other tools that do the same. So what we have here is a single storage for our layers. And those layers are completely deduplicated on the storage level, which means that they're always the same layers. And we can decide in which of those registries those layers will appear as part of an image. And we can have as many as we like local proxies, and then the promotion between them is just a REST API command or a JFrog CLI call or one of our CI plugins execution. What actually happens here is that we send this API call, and then an image that was here suddenly appears in testing, or next it appears in staging, and next it appears in production. And all that without moving a single byte, not only over the network, but also on the disk. It's all just a matter of where it represented. Another concept, caching of remote images with the degraded, I would say, stability of Docker Hub lately, this becomes of more importance. And this is once you downloaded your base image once from Docker Hub, it will be cached in the tool and you will just use it whenever you like. And the virtual, which is kind of a gateway to any number of other registries, and it provides a single point of access for your CI and for your developers. And when your CI deploys a Docker image, the one that was built once, it will be deployed to the dev local, and from there the pipeline will start. And here is the representation of the quality gates and the isolation that I mentioned. Once we have multiple registries in the tool, we can actually isolate the environment to see only the correct registry. And now the production cluster won't have any access or even knowledge of other registries in your system except of Docker prod local. That's the only registry it will work with, and this is how you can guarantee that it will only get the production quality images. Also note how the CI here cannot deploy, or your developer cannot deploy, and again based on visibility and authentication and authorization, cannot deploy to anything except of Docker Dev Local. They cannot shortcut your pipeline and just push something to your production registry. It has to go through the promotion pipeline. The only way to get from dev local to .local is through all the quality gates that we intended it to go. So this is how you guarantee that you only build once, and that whatever gets to production is only the result of going through the entire pipeline. So we have a win-win-win here. So we do have a single point of access to multiple registries when needed, and we also have completely isolated environments, and we have a mandatory, immediate, and free promotion between the environments that guarantee that you cannot push directly to production, and it also guarantees that when you need to promote, it will be immediate and free. So another aspect that I mentioned in the beginning is how relying on latest is dangerous, which is true, but latest is a nice concept. We have it in a lot of languages. We have the snapshot in a lot of dependency managers. We have the snapshot in Maven, for example, and it's really compelling because it's really easy to use. You just use latest and push it to production, and then there is latest in production. And if you want to know what this latest relates to, even half a year from now, if you use tool like what JFrog provides, JFrog Container Registry, JFrog Artifactory, you can actually do it through metadata. So here is our latest image, and its manifest has tons of different metadata. How it was built, in which build name, in which build number, when it was built, and all the manifest and what's not, but also it has a custom metadata that refers it to its real tag. So Docker, the latest, and it is actually 26. And the beauty of it is that it's not two different images. This is what we spoke about. It's completely deduplicated by layers, so the layers are exactly the same. It's just we have a different manifest that shows it as different tags, but it's actually the same image. And this also a win-win. We have the simplicity of latest. We can go back and use it without being terrified that we have no idea what's going on, and we also know what it really means, as long as no one actually pushed a new tag and a new image under the same tag 26. And we come back here to this problem of Docker tags not being immutable. You can work around it with tools that have role-based authentication and authorization controls. And what I mean is you can actually prevent delete operation, and override requires a delete operation. And this is how you will prevent override of a tag. And that's a good practice. So as long as you promote immutable artifact and you didn't override the tags, latest are not a problem anymore, because it will always refer to the same tag, which will also always be immutable. So the last point is the rest of the dependencies. So yes, we promoted our own immutable layer. Great. What about our dependencies? Are they immutable as well? And that's a valid question. Remember, even if we rely on Ubuntu 1904, it can change. So how do we guarantee that our dependencies won't change in any time and it will be the same dependencies? For base layers, we have the remote registry that caches Docker Hub or any other source of our base image. So this is checked. And for the rest of our dependencies, if you use full version of Artifactory, you probably have the right type of repository for whatever dependency you use. If you use Maven, if you use Java, you have the Maven and the Gradle repositories. If you use Python, you have the PyPy. If you have JavaScript, you have the Node. So every dependency has its own type, and Artifactory has support for all of them. If you use the JFrog Container Registry, which is free but limited in scope, you have still a good solution, which is called the generic repo. Generic repo is a place that you can host any kind of artifacts, including your dependencies. So here you can see an example how we host our infrastructure dependencies in a generic repo. Here is our JDK and our Apache Tomcat, and also our applicative dependency, our Java application inside the generic repository of our dependencies. So we cache the base image in the remote repo, in the remote registry, and then we cache the infrastructure, we store the infrastructure and the application files in the generic repository. So just to conclude, build only once, separate environments, promote what you have built, and own your dependencies. Those are the best practices for a promotion pipeline. The tool is not relevant. You can do it with any tool that supports this. And what you need to remember is those practices. With that, thank you very much. Q&A now. I'm at JBaruch on Twitter. I came up with the hashtag Utah Kubernetes. I don't know if it's a real thing, but let's make it a real thing. If you mention this talk online, let's use it. Let's see what comes out of it. And jfrog.com/show notes. This is where the slides are and all the links, and obviously the raffle that we spoke so much about today. So with that, Q&A.
Wonderful. Anybody, please.
Yeah, I had one question. So basically, you're controlling the pipeline and where your image is coming from by kind of controlling registries, right? What do you think of? And I don't know what the status of this is, but what do you think of using image signing instead of using, like, you're saying, like, I know that what I'm running is good because it's coming from a place that I trust. Well, I know that for a while there we were talking about image signing as being the solution. Is that really not panned out? I've kind of been out of the loop on that for a while.
Like Notary, is that what you're thinking?
Yeah, Notary, and like, because that's the alternative is like, I can trust this image because it's signed by the authority and the only thing that could have signed this was the thing that passed my, ready for prod checks.
Yeah. So that's another good alternative. And what you say is we can make quality gates signing our images with different signatures, and then we can set up our environments to only accept images with the signatures of the right notary of the right quality gate.
Right.
This is definitely an option, but implementing it will be much more complicated than just having different registries, because having different registries, this is something that, or accepting an image from a certain registry, this is a base functionality on any Docker runtime, because you in any descriptor, the simplest that it's be, you are going to say get the image from this registry. This is like basic 101. Now, implementing check of signatures is much more complicated. And I would say it's way, it's an overkill. Signatures are important for establishing trust. The issue that we solve here is an issue of visibility, not necessarily trust. They're related. You can build trust system instead of visibility system. It will be much more complicated to implement.
Okay, yeah, I can see that point. With the separate registry, you can kind of look at the registry and say, like, well, everything here is ready for prod because it's here.
And exactly, and it's much easier for me to implement a system that will be less breakable because, well, it's simpler.
Yeah, that's a fair point.
That pattern also applies for those other registries much more cleanly than trying to implement signing in, Node or other places. So it's a much more applicable pattern for sure.
Yeah.
The trick, I think, when we kind of discuss some of this in other places, I think is controlling your end destination, right? If somebody can just create pods willy-nilly on your Kubernetes clusters, they can just create it from Docker Hub, right? And so
not if you put an OPA policy on it.
Yeah, I'd say unless you go in with some sort of policy that says like you're not allowed to even use an image not from this place.
Yep.
Exactly.
But not on the downside of the tool.
Well, no, this is legitimate, and then the question is how easy the policy looks like. And if the policy looks like this is the only registry you know, and those are the only credentials that you have, and good luck trying to get images from other places, this is simple.
Right. Except, yeah, the side step there is public Docker Hub registries where you don't need credentials and you can just go pull.
Yeah, no, you block all of that, and you nail everything down to Artifactory, and you say you only use this registry, which is Artifactory, and inside Artifactory you will have a fun time having everything because you have remote registries, and you bring everything from Docker Hub anyway. So
sure, no, that makes sense.
Yeah.
There's also kind of a movement of testing in production.
Absolutely.
Some people call it an anti-pattern. Some people think it's the best practice. In that case, there's a single cluster and other things that are just basically not divided in these gates. What are your thoughts about that? Maybe not just in testing and production, but let's say it is a good thing or that you've chosen to do that. How would you?
I love this topic. I love this topic because it's such an abused hype that it's just a pleasure to talk about. Now, what I mean is that people get agitated about testing in production for good and for bad. Some people say it's a horrible idea. Other people say, well, that's unavoidable. And both are actually correct. It's a horrible idea, which is unavoidable. And what I mean by that is that with the complexity of software we are facing today, and the amount of data that that more and more organizations have to process, the idea that we can build a staging environment that will be in complete parity with production is out of the window. It does not exist anymore. Because replicating all the data doesn't make sense, because we cannot simulate all the requests that we have from different types and in different scale. So there will be untested parts of our application. Does it mean that we throw away the entire pipeline and just deploy whatever we code directly to production? Of course not. And that's because testing in production is horrible. It's a really, really bad idea. We have to do it. It doesn't mean that we should not do everything else. So we build the pipeline to the best of our ability. We make it as rigid as possible. We implement the most tests that we can, and then in the end of the day, we will also test in production. But that's not a replacement for our pipeline.
So give me an example a little bit of I have one cluster. That pipeline would go between, again, would you have the separate registries, dev, test, whatever, and then how would you just have isolation of the namespace with other policies or whatever, and then you'd say, okay, now promote this one from that registry and then promote this one from that registry. Is that kind of the thought? You still have separate registries?
Yeah, absolutely. So even if you have one cluster, you have some kind of network segmentation using a server mesh or whatever, and you can say, well, this part of the cluster is now my integration environment, and this part of the cluster will run images from this registry, which is my integration registry. And this part of the cluster is my staging environment, so it will run images from my staging registry, and the rest of it is production, so they will only access images in my production registry.
Okay. Have you seen many do that as far as?
Yeah. Yeah. So absolutely, we see more and more. So what you see here can be kind of retrofitted into. So I hope I gave you best practices of how to work with Docker and with Docker images in general. And again, I encourage you to go and look for other tools that do these practices in the way that we do it, or even better. But the same concepts we go and show to our customers when they buy JFrog platform, and they come to us and say, okay, what do we do with this thing? We say, here are the repositories and the registries that are best practices in this industry. So at least we hope that a big a chunk of the whatever 6,500 customers that we have implement those practices, and this is how they use it. And obviously there are tons of people outside do it with different tools and different techniques, but the concept of isolating the environments is critical. It's just a matter of how hard you should work for it, and we hope that we make the life of our customers and users a little bit better by having that baked into the free product and into the commercial product, like everywhere.
Thank you. Any other questions? Greg?
I was just to say that isolation is actually key. If you share nodes, there are artifacts that are generated when you pull an image, and we had dev images showing up on our prod namespaces and copying like what's going on, and just realizing it was the same SHA from a previous dev deployment on that node, and it got cached. And I don't think any of the policy stuff would have prevented it, but if you query the Docker API and ask for what's this SHA, it might give you back a different tag than you were expecting, because it is that tag as well. It can have multiple names. So isolation definitely is something to keep in mind. If you want to make sure those things don't happen, you can't run pods on the same nodes.
And now you have Greg here. I didn't pay him, but it's great to hear that this problem is not something that I invented to scare you and push you towards JFrog tools. It's actually a real concern, and thank you for sharing that.
Anyone else? Well, Baruch, I'm amazed that you've, this is back-to-back presentation, right?
No, but I mean, Ari has no mercy, so he just.
Oh yeah, I mean, I get triple overtime on this one, man.
No, I mean, I'm happy to be here, and I'm happy to share it with you, obviously. And look at him; he's very happy that he made us do it.
Actually, I went and told my wife. I told my wife what I did, and they're like, they hate you, don't they?
No, we love you, Ari. This is great, and thank you for helping us and helping the meetups organizing that, because I think it's the operation that we kind of build up here is great for everybody. So thank you for Paul for having us, and thank you, Ari, for organizing that.
Yep. Well, thank you all. As I said before, you had links. Well, let's see. I'm recording it. I'll make sure there's a link for that, as well as the other links for what you put out there as well. So Ari, Deep, who's not there anymore, but thank him again. And Baruch, thank you so much. We appreciate you.
Paul, hopefully next time in person, if there are places that I really love, Utah is definitely very high on this list.
Oh, you'd love it.
And I really hope we will make another one in person soon enough.
And if you love to ski, let's do it during the winter.
Yeah, that's a great idea.
All right. Well, take care, everyone. Thanks again.
Thank you.
Bye-bye.
Bye-bye.
Have a good night.
Greg, you still there? No, I lost him.